Dear students, in the last video we studied the example 1.6. Now in this video we will observe or we will see the example number 1.7. See what is given in that example. The equilateral triangle is given. On the vertices of the equilateral triangle the charges are kept. This is given, right? The Q charge is kept on the A vertices, the Q charge is kept on the B vertices, and minus Q charge is kept on the C vertices. The diagram is given in the question, right? So it is equilateral triangle and the question is find forces on each charge. Net force we want to calculate. So net force, suppose denoted by letter FR or F net, we can write the force, resultant force on each charge. So force acting on A vertices, suppose force acting on B vertices and force acting on C vertices, means force acting on this Q charge, force acting on this charge and force acting on this charge, that we want to calculate like this. This is our equation number 1, right? So what is FA? Means force acting on A. So force acting on A, this is the force acting on A. See how we can draw force acting on A due to the B, means force acting on this charge due to this charge. This is plus, this is plus. So force acting on this due to this will be directed like this. So this is the force acting on A due to B. So FA equal to, we can write force acting on A due to B. Also the force acting on A due to C, right, on this. This is plus, this is minus. So it will be attractive one. So this is a force acting on A due to C, right. So this is the force acting on A. How many forces are acting on A? These two, this one and this one, FAB and FAC. These are the two forces acting on A. Similarly, calculate the forces acting on B. Force acting on B due to A, it will be, this is plus, this is plus. This force will be repelling force. This will be like this. Force acting on B due to A. What is the force acting on B due to C? That will be a, this is minus, this is plus, it will be attractive one. So force acting on B due to C, right? C. Next, over here. What is the force acting on C due to A? It will be a attractive in nature. So force acting on C due to A, right? Force will be attractive. This is minus, this is plus, so force will be attractive. Similarly, force acting on C due to B, it will be a attractive in nature, right? So like this. So this is the force acting on C due to B, correct? So we calculated over here force acting on A, two forces, this FAC, FAB. What is the force acting on B? Force acting on B will be these two forces. So that is, that we can write force acting on B due to A, force acting on B due to C. These two forces. What are the forces acting on C? Force acting on C, that is this and this. Force acting on C due to A, force acting on C due to B. Put the value, put in 1, equation number 1. So net force, that is FR equal to, we can write force acting on A. The force acting on A due to B plus force acting on A due to C. What is the force acting on B? The force acting on B due to A, force acting on B due to C. What is the force acting on C charge? Force acting on C due to A, force acting on C due to B, right? But from the diagram, what we can say? We can say that, see, observe the diagram, this force and this force are equal in magnitude and opposite direction. So we can write FAC equal to minus of FCA, correct? These two forces are opposite in direction, FAC and FCA. FAC is minus of FCA. Similarly, what we can write over here? See what we can write. F, right? FBC equal to, we can write minus of FCB. See the diagram. And here this FAB and this FBA are again in the opposite in direction. So FAB equal to minus of FBA, right? Equation number, suppose we will write, it is a second equation. Put in second, all these values put in second. So FR equal to FAC, see it is FAB. So FAB equal to, we can write minus of FBA, correct? Completed. FAC equal to what? Minus of FCA plus, what is FBA? FBA, it is remains as it is, FBA plus FBC. So this FBC equal to, we can write minus of FCB plus FCA as it is, FCA plus FCB remains as it is. See, this is a plus, this is minus, this is plus, this is a, right, get cancel. FCA, this is a minus value, this is plus value, so this get cancel, right? And this is plus, this is minus, this is also get cancel. So FR equal to 0. The net resultant force acting on all the charges are 0. This is the end of your numerical. You just take the screenshot and we will see the next example, example number 1.8. Just take the screenshot. Okay students, now we will see the example number 1.8. Example number 1.8. This example is asked already in the March 2020, right? This example was asked in March 2020. See the example 1.8. What is given? The two charge plates are given like this. The diagram is given. This diagram is given. This is the A diagram and this is the B diagram. The charges are, this charge plate inverted. The distance between these two charge plates is given, that is D. This D equal to 1.5 centimeter, 10 to the power minus 2 meter. The electric field between these, the electric field is directed like this from positive to negative, positive to negative, positive to negative, right? The electric field is given E equal to 4 into whatever, what is the electric field, that is 2 into 10 to the power 4 Newton per Coulomb. This is the electric field given, right? So suppose the electron is kept over here. This, what is the time required to cover this much distance by this electron? So time of electron means time required to cover this distance for this electron. Electron is kept in the electric field E equal to 2 into 10 to the power 4. This is the electric field over here. In the second case, proton is kept over here. So what is the time for proton? Right? That is question. One by one we are going to solve. Right? Time of electron and time of proton. Calculate the time of electron and time of proton. Time of electron means the time required to cover this 1.5 distance. Right? Electron having negative charge, so it will be repelled by the negative plate and it will move towards the positive plate, means it will accelerate, right, towards this positive plate. So what is the time? We can see this situation, we can consider this situation as the time. It is the case of free fall. Electron is falling down, means it is falling towards the positive charge particles in the absence of gravitational field. So it is the case of free fall. So according to the free fall, what we can say that this distance, suppose this distance denoted by letter d. So using the equation of motion, d equal to v0t plus half at square. Right? Here v0 is the initial velocity, a is the acceleration and t is the time required to cover this d distance. So if it is the case of free fall, for the free fall, initial velocity v0 equal to 0, put the v0 equal to 0 in above equation, d equal to 0 plus this becomes 0, means 0 multiplied by t becomes 0, half of at square. So a is the acceleration. This is suppose equation number 1 we can write, this is the equation number 2 we can write, right? But for the a we are going to calculate. We know that F equal to m into a. So therefore a equal to we can write F by m. But here force is electrical force, here electric force. So that's why we will write a equal to F equal to we can write Q into E divided by this mass. So put the value of acceleration over here. So this distance d equal to 0 plus means plus of this half, instead of a we are going to write q into E by this m into the t square. Right? Okay. We are interested to find the value of t. So t equal to we will write, so t square equal to 2dm divided by qe, q into E, q into E. Suppose taking square root on both sides, so t equal to under root 2d into the m divided by q into the E. This is your general equation for time. Now for electron, time of electron means Te equal to under root 2 remains as it is, d means distance that is given, and that is equal to 1.5 10 to the power minus 2 into m. M means mass of electron. First of all, we will make the general equation for the equation for electron, that is 2d remains as it is, m is the mass of electron over here, and q means charge particle is electron over here. So we will write E only into this electric field E. Now putting all the values, 2 into 1.5 10 to the power minus 2, mass of electron that we know that, and it is given mass of electron is 9.1 10 to the power minus 31 kg divided by E means magnitude of electron, that is 1.6 10 to the power minus 19 multiplied by E is given, that is 2 into 10 to the power 4 Newton per Coulomb. By solving this, you will get the answer, and that answer is nearly equal to, that is time of electron, that is 2.92 10 to the power minus 9 second, means 2.92 nanosecond. This is the time required to electron, time required for electron. Now we will discuss the time for proton. So our equation is, see our equation number, this equation number 3. Time for proton means Tp, 2 d as it is, m is the mass of proton we can write, and for the q we will write proton, electric field remains as it is. So time of proton Tp equal to under root 2 d mass of proton divided by p, we can write. Charge particle is p over here, and this E remains as it is. Okay. Now putting the value 2 into d means that is 1.5 10 to the power minus 2, mass of proton that is given 1.6 10 to the power minus 27, right, and magnitude of proton, that is 1.6 10 to the power minus 19. E means electric field, the magnitude of electric field is given 2 into 10 to the power 4. Dear students, by solving this you will get the answer, that is Tp equal to 125.1 10 to the power minus 9 seconds, right? So also Tp equal to 125.1 nanosecond. So this is the time for proton, and we can say that time for proton is very greater than time for electron, that we can say. So this is the first part of the numerical. You just take the screenshot of this numerical, example number 1.8. Take the screenshot. Okay, this is the first part of the numerical, and the second part, in the second part we are going to calculate the accelerations of electron and acceleration of proton. So removing this, in the second part B part of the numerical, acceleration of electron. How we can calculate acceleration? It's very simple. F equal to m into a. So a equal to what? F by n. Here the force is electrical force, so we will write q into E by m. So acceleration, the general formula for a equal to what? Q E by m. This is the general formula for acceleration. Now acceleration for electron. See, acceleration for electron, right? So AE equal to, instead of Q we will write E, charge particle is E over here, E by mass of electron. Put the value. E equal to, we know that is 1.6 10 to the power minus 19 electric field is given, that is 2 into 10 to the power 4. Mass of electron is given 9.1 10 to the power minus 31. Calculate your answer, right? Next, that is acceleration for proton. So AP equal to, we can write P into E. Charge particle is proton, that's why we will write P into mass of P. So what is P? Again, magnitude of charge on proton, that is 1.6 10 to the power minus 19. The value of E is given, that is 2 into 10 to the power 4, and the mass of proton, that is 1.67 10 to the power minus 27 kg. Calculate your answer, and here is the end of your numerical. Correct? So in this way we completed the example number 1.8. In the next we will see the next numericals. You just take the screenshot of this numerical, right? It is not here. This is a homework for you, to calculate the values of acceleration and proton, acceleration of electron and acceleration of proton. Okay, thank you. In the next video we will see the next examples.